comrades. We're going to look at AS Chemistry November Test question 22 now, which is analysis of a titration. So in this one, we start with a student carrying out a titration to determine the concentration of hydrochloric acid. Student titrates the hydrochloric acid against a standard solution of sodium carbonate. We have Na2CO3 plus 2HCl goes to 2NaCl plus H2O and CO2. Student prepares 0.150 moles of Na2CO3 in a 250 centimetre volumetric flask, and the hydrochloric acid added is in a 50 centimetre cube pipette. The student pipettes the Na2CO3 using a 25 centimetre cube pipette, and the student's burette readings are shown in the table below. The rough titer has been omitted, and so these are just their full attempts at working out the titer. First of all, complete the table. So the first one had 24.60 and its initial reading was 0.40. Notice they're going to two decimal places. You also have to. If you just put 24.2 here, if I'm taking these away, you would lose the mark. So you needed to add that 0 on. You're showing how precise you're going here. So in the next one, we've got 28.45 and 48.45 and 24.60, which will be 23.85, and then 34.30 and 10.00 gives you 24.30. So part 2, calculate the mean titer of HCl to the nearest 0.05 centimetres cubed that the student should use for analysing the results. So we only want concordant results, ones that are close together. So these two fit that bill. This one is too far off, so we're omitting that one. So that one can go. So the average will be 24.20 plus 24.30 divided by 2 to give you 24.25 centimetres cubed. Then we need to calculate the concentration in moles per decimetre cubed of the hydrochloric acid. So into our table, I'm going to put all the information I've got so far. So we know, if I do NCV up here, I know the concentration of my sodium carbonate was 0.150 moles per decimetre cubed. I'm not going to have enough room if I put the units in as well. Then we want to work out the concentration of the HCl. We know the volume of Na2CO3 was 25 centimetres cubed. I'm going to put the units here because it's important for that one. And we also know that the average over here for the HCl added was 24.25 centimetres cubed. So once you've got that in, you can start to look, oh, well, what can I work out? And there's nothing on the HCl side, because I've only got one piece of information. But on this side, I do have two bits of information. So the first thing I can do is work out the number of moles of sodium carbonate. And that will be N equals C times V. And I'll have to divide by 1,000, because this is in centimetres cubed, which is why I left my units in, so I remember here. So N equals 0.150 times 25 divided by 1,000, which will give you 3.75 times 10 to the minus 3 moles. So up here on my table, number 1, and go 3.75 times 10 to the minus 3. Now, using stoichiometry, I can see that I can then work out a number 2, what the HCl is going to be. Now this, for every 1 mole of sodium carbonate, I'm going to get 2 moles of HCl. You can tell that by looking at the balancing numbers. So this is a 1 to 2. So if I've got 3.75 times 10 to the minus 3, moles of sodium carbonate. I'm going to times that by 2, and that's going to give me 7.5 times 10 to the minus 3 moles of HCl. So now I've got 2 bits of information on here, I can finally have a look at what the concentration is. So I'll need to rearrange this equation, and rearranging it gives me C equals N over V times 1,000. So this is in centimetres cubed. I've got to times by 1,000 here. If I put everything into this, I'll have 7.5 times 10 to the minus 3 over 24.25 times 1,000, and that gives me a concentration of 0.309. It asks me to go to 3 significant figures, so up here concentration will be 0.309 moles per decimetre cubed from rearranging that equation. So that was 3 steps in this, and each one gets you a mark. And that is question 22.